Hello, everyone. I see folks are trickling in. It's a beautiful day. We're happy to be here. Just give 30 seconds for folks to join. All right, let's go ahead and get started, and folks can join as they come. All right, well, hello, everyone. Thanks so much for joining us today. I am Elizabeth. I'm a marketing lead here at Resolve. And for those of you who aren't familiar, we are building AI for prod that helps teams resolve incidents faster and code with full production context, which is our topic today. So, on our panel, we have with us Josh Gross, who is a founding team member focused on customer and developer success here at Resolve, along with our very special guest speaker, Chris Umbel, who joins us from Zscaler. He's a senior principal SRE running site reliability at scale. And so, before we begin, I just want to go through a few housekeeping items. We will be recording this session for those of you here and for those of you who could not make it. And throughout the session, you will have access to a Q&A, which you can find at the bottom of your screen. We'll have some team members in the chat. Shout out to Manveer here and Rebecca, who will be answering any questions and helping moderate as needed. And at the end of the session, we will leave time for a brief Q&A with our panelists here. And so with that, thank you for being here. I'm very excited to pass it off to Josh to get us started.
Awesome. Thank you, Elizabeth. So I think we wouldn't be doing it justice unless we started with a little bit more about like what we're going to be talking about and why Zscaler chose to work with Resolve on this problem. And so if we just kind of set the groundwork, when we started thinking about like our team, we're behind Open Telemetry, so we co-created that. We've worked in observability, both at Splunk, but also at Omnition. One thing that we realized was there was this belief that, you know what, like developers spend all this time coding. Operations really is like the last mile for everything. And so best case scenario, we were thinking, okay, like developers spend 50% of their time coding, 50% of their time doing whatever else it is. Some of that might be on call, others capacity planning, you name it. But in reality, there's been a number of studies on this. Only 16% of the time developers are actually spending on coding. And so that got us thinking, like, what are they spending all their time on? And so what we started to figure out was it's what we're labeling production, but it's everything from maintenance, it's planning for new refactors, capacity planning, events, features, documentation, you name it. And I'd like to think that this ratio is changing, but it really isn't. Like we live in this bubble, like we work out of San Francisco. Our team, I think, we just surpassed 120 folks, both in the AI domain, observability, backend systems, infrastructure, you name it. And yes, PR throughput is through the roof, but it actually hasn't changed this equation all that much. Like code reviews are taking longer. Incidents are happening more frequently, even if you don't want to talk about it. And so we realized that, you know what, we're at the front of the wave because it hasn't hit all the companies we talk to yet in terms of that PR throughput actually impacting our ability to understand production. Like I talk to engineers all the time. They're like, yeah, I YOLO it a lot more than I probably should. And that's scary, to be honest. I like laugh, but uncomfortably. And so why is it so challenging? Well, number one, when you think about it, like many of you, especially if you're attending a webinar about Zscaler, you probably are at some level of scale. And so you understand how fragmented the systems are. Some is by design, some is by innovation. But what that means is you have to create all this expertise or these specialized skills, these specialized teams to be able to, one, procure and use tools that help them better understand their environments, troubleshoot, build, etc. And so when things break, it trickles through everywhere. The challenge is, yeah, you might do postmortems. You may have run books that are outdated. We all know that if we're in incidents. But that knowledge is never really captured, and it's not really transferable either. And worse yet, it's never really up to date. And so when you think about like production and the challenges in approaching this from an AI perspective, they are numerous. But this is also why Like we build these systems, whether it's like Knox and L1 and L2, run books and SOPs, escalation paths, postmortems, all these things. We build a process to make it predictable. But that comes at a huge cost and burden to the organization. And so when you start to think about like the impact of these, say, costs or these investments to scale and grow, like it's not just incidents. It's everything from like we over provision. It takes a new engineer 3 to 6 months to be able to go on call. I have some customers, the problem they came to us was, why are there 100 engineers on every incident bridge? Sometimes that is seen as a good thing because everyone wants to be involved, but chances are you have competing theories and all these other challenges. And so, yes, we're here to talk about AI for prod. I'm going to show you some information around how we actually troubleshoot with Resolve for incidents, but it goes so much beyond that. And so we see this as, again, it's the front of the wave. Like it's just going to get worse. You're shipping more features, more prototypes. We're using infrastructure that we never would have thought of for inference 2 years ago. And so we have a lot more providers. Everything is more complex. And so, what do? We fight AI with AI. And so, this is how we do it. And so, at Resolve, what we've done is we've built an agentic solution that taps into your infrastructure and the tooling that you use to not only generate a body of knowledge that we can use to understand, oh, this thing is related to this. So, it's essentially called a knowledge graph. We also use these tools. So whether it's your deployment infrastructure, your observability tools, your alerting infrastructure, even your runbooks and your documentation, we use those at runtime to help facilitate our ability to answer questions or triage alerts. In addition, one of the challenges in the space, like I mentioned, a lot of stuff isn't really documented, it's not up to date, but you have subject matter experts all throughout your organization that know what to do when SH hits the fan. And so we try and get that information out of their heads by creating a construct so that our agents can use that. And the feedback loops have to be very small to encourage that. What it gets you, though, is this yes, it is definitely tuned just for incidents. You're going to see how well it can work, whether it's from a simple alert, whether we join in an incident channel, or whether it's a human prompting us. However, you can imagine all that you could answer with this type of understanding of your environment. So, um, many companies have chosen to work with us. We're really excited, of course, to be able to do these presentations with Zscaler. We've done one with Coinbase as well at reInvent, DoorDash in some of their most complex environments where there are plenty of abstraction. So many of you might be working with like critical user journeys, slows. How do you triage those? You need a lot of context to understand what tools do I look at in what order. That's what we're helping companies like DoorDash with. A number of others would love for your logo to actually be on here as well. So what we're going to focus on in this brief demo is going to be an incident. That's something that any of you are on call. You've experienced receiving an alert. And so how do we triage it better using AI? I'm also going to do a little derivative or deviation from that just so that you can see the other side of the coin. Because if you are a big enough company, especially selling to enterprises or working with companies like that, or even consumers, chances are a lot of your incidents still come from those users reporting them. That kind of sucks, but that's what happens when you have a lot of alerts. And so I'll show you how the other side of the coin with that same incident. And if we still have a little bit of more time, but I know you're here to see Chris, I might have a little bit more fun. So let's go ahead and get into it. All right. So many of you are probably familiar with this. It's not like you pay attention. In fact, you might have a muting rule unless you're on call. But many of our customers, you've got alerts streaming in to channels. These have different prioritization. There's a payload. Maybe there's dashboards attached, metrics, and so forth. When you get an alert like this, Kafka consumer is high, you're like, oh, crap, Kafka's always hard to debug. But the first thing you're going to do is you're going to go and look at the alert and you're going to look for, okay, is there a dashboard that I can look at? And yes, there is one. But what if you didn't have to do that? What if Resolve received this alert? And the first thing that we're going to do is we're going to say, okay, Kafka, do we know where Kafka exists within your environment? What depends on it? What are the producers, the consumers? What are the configurations at the broker level? Now, with that body of knowledge, let's go and gather evidence. So let's triage like a human would. So rather than look at 40 charts for the anomalies, let the AI do that. So within a minute, we're starting to produce this evidence. We're not at a reasoning phase, but we want to give you information as we get it. So that can also inform you. Chances are this information is actually flooding in before you even acknowledged a page. And so in those first couple minutes, we're telling you what we've done. So we looked at the metrics, the consumer lag for these services peaked. Great. Now I kind of know the impact. How bad is this? We looked at traces here and we saw systemic 1 second delays. Okay. And it's affecting this many messages. We checked the logs. Oh, interesting. There was a config change that was made that may be related to it. We also were able to look into Kafka and understand what actually happened by processing and understanding those logs, as well as the metrics and dashboards associated with it. And then within the traces and the metadata in there, we were able to assert that, okay, 100% of these failures were related to traces or spans that had this value, okay? But we haven't told you that's our conclusion yet. We're just feeding you the information that we found. And all of this is generated via what's called a planner. This is essentially the orchestration that occurs. Now we started looking at code and bootstrapping, but at this time, we actually figured out, you know what, we have a really high confidence that we know why this is wrong, this is happening. And so we gave you a quick summary. So this is one of the challenges. If any of you are very active in AI, the hardest thing about it right now is how verbose it is. That's why within Slack, it's really important to us to feed you information quickly, then clean it all up. And so here you're seeing the theories that we came up with, our confidence rating, as well as the findings. And each of these findings, it has a source. So that source is going to go directly into Resolve to the tools that you are already using. So if I wanted to say, okay, at Resolve, is this still going on? This is what you would do from your bed at like 2 a.m. when an alert fires. Rather than go and open up your laptop, let's just ask Resolve if this is something that has already resolved itself. And Resolve can answer that by using, again, the tools to go and check how do the metrics look? How do the logs look? And these type of questions, these can take 30 seconds, a minute. But for these investigations themselves, depending on the number of tools that we actually have to use, it's going to take anywhere from, depending on the time, 10 minutes, something around that, okay? But you're going to be given feedback and information throughout. Now, while that's populating, I want to show you exactly what this looks like within Resolve, because you can imagine like, hey, I would like to trust this, but you know what? It's really hard to do so. Or maybe this gets escalated to you. If it's escalated to you, you don't want to see a bunch of charts that a human has said, hey, I think this might be it. I ran this query. You've never seen that before. Instead, it's so much nicer when you have something like this, where it's essentially a timeline of everything that we've observed with the impact, the severity, charts that are coming directly from the metrics that you use, but we've simplified it, we've curated it. So we're not just sending you directly to the dashboards themselves. We're giving you the start and peak times, when it fired. And again, this is all data that's coming from your systems that's happening at runtime. We're identifying patterns. Uh-oh, we've also noticed that this keeps happening. So now you start to understand, okay, now I really am getting to understand what's going on here, the impact. We also did some other checks. These checks are important because when you think about it, everybody wants this to just get straight to root cause, but you have to validate that that theory is accurate. The only way to do that is to try and invalidate it. And so here we checked AWS as well. Here is the summary of what we found. We built a visualization, so a mermaid diagram that can be copied across a number of formats. The additional evidence, suggested next steps. If you want to understand how to fix this, we can even generate PRs for you, okay? And so here is the report that is generated. If you wanted to, why don't we just do that? So here, if we go back into this chat, interestingly enough, we went and we chatted with it right up here. So here's the alert. It came down. If we wanted to, at Resolve, actually, I don't even need to do that. Can you create a PR to permanently disable this flag? And Resolve can do that as well. While it is doing that, I want to show you one other thing. So we just saw one side of the equation where an alert fired on Kafka. Hopefully someone looked at it. But that same thing is happening on the other side of the equation, which is what actually was the impact and who was impacted and who felt it and how would they describe it? So before the demo, I was having a little fun. I said, I sent myself an email and I said, hey, there's a flurry of chargebacks stemming from around 3 p.m. on this day. Okay. So you can think of this as like, hey, this is your finance department or something like that. I'm like, hey, Josh, we just received a number of chargeback requests from yesterday and are trying to get to the bottom of this. Did you see anything that may be related from your side? Well, how can we make an AI that can take chargebacks and understand it's related to fraud detection and then go and troubleshoot the fraud detection, which would have to go upstream to Kafka? That is the beauty of this, and that is why like these tools are so dang powerful. So we've got like computer vision, of course, to take that image. Resolve use knowledge. So this is where all that orchestration and how do I get all that great context I have in my head out into the system? So these are MD files, just like what you're using with Claude, with Cursor. And it was able to find these sections within these MD files that are related to just this simple prompt. I should have been nicer with my prompt, to be honest. And then it takes us through and it starts to, again, do what you just saw in Slack, but sequentially start to gather information. It starts to find information here. It says, okay, it looks like there was a processing lag caused fraud detection. Here's the timeline of the incident. Here are the key details that we saw. It asked me, would you like me to investigate what caused it to stop processing messages? Sure. I didn't say please. I've gotten away from that. What happened? Feature flag was enabled. So we just saw two different sides of the same incident, whether it's coming from the knock or it's coming from the on-caller. Like that is the beauty of it. Dang, I want to go more, but I feel like it's not fair to Chris. So I'm going, well, we can come back if there's time. Chris, I think it's time for you to talk about your story.
Awesome. Thanks. Yeah, and at this point, it's funny. It's been how many years since Gen AI became mainstream? And I think it was just within the last week I finally stopped saying please to it. Um,
I actually erase it sometimes. So I
yeah.
was like, no more token use.
So can everyone see my screen? Give me a thumbs up there,
Yep.
Josh. Cool.
Yep. Looks good.
Thanks, everyone. I'm going to talk to you a little bit here about what we at Zscaler are doing with our partnership with Resolve. I am Chris, as was mentioned. If you ask HR, they'll tell you that I'm a site reliability engineer at Zscaler. It's kind of half the story. I also function as the AI ops lead, where my role is to participate and supervise the development and procurement of AI tools that assist in our operations, particularly pertaining to incident response. I'm going to set things up with a bit of a description about what Zscaler does and what kind of systems we operate, because I think that motivates a bit of an understanding as to why our use case might be particularly interesting to especially people in the enterprise space and outside of the startup space. We are the world's largest zero trust provider platform. Translates to about a little over 9,000 entities that we call customers. Those do tend to be large. 30-ish% of the Forbes Global 2000 is indicated here, does consider us customers. So large enterprises, governments, that kind of thing. Small shops as well, but we sort of focus on enterprises. Translates to about 50 million individual human being users. And for those 50 million human being users, on a daily basis, we stop about 9 billion-ish bad things from happening. What that would mean would be one of these users tries to download a virus or accidentally disclose their GitHub keys or whatever. Our job is to sit in the middle of their traffic, all of the traffic for that organization that's coming from users, and apply policies and block what's bad and allow what's good. So, it sort of looks like the diagram that you see on the right here, where we are literally the internet access for most of these organizations. We are in the middle of it all, and that means we have a large global network to make that happen. Traffic coming from a user's workstation or laptop going out to the internet to browse the news or even do some work, that goes through us, and we apply policies to it. Even traffic going back into the data center, into private applications, we're applying policies to make sure that not only we trust the user, but we also trust the device and their location. And we sort of sit at the center there, ensuring that everything's safe. Um, and like some of these numbers might be a bit hard to abstract, but think of it as like that's 500 billion-ish transactions per day, and think of a transaction more or less as like a request flowing through the system. And it takes hundreds of thousands of systems in order to make that work. So things that you might think of as a computer, hundreds of thousands of these make up our infrastructure. The tech stack that we use is bespoke. It is highly custom. It doesn't look like the kind of thing you're going to see anywhere else. It is made by us for us. It is overwhelmingly bare metal. It is not entirely bare metal. It is mostly bare metal. But there are also very important pieces of it that run with all the major hyperscalers, as well as bits that even run really on customer prem that fall within our purview. But it's that bare metal core that is what most of this traffic flows through and provides most of the value. That spans about 160 data centers, not including everything that we do on public cloud. But it's incredibly performance sensitive code that makes this work. Don't think of this as CRUD applications. Think of it more as globally distributed firewall firmware at ridiculous scale. But in addition to that, there's also, traditional business applications that make all of this work and glue it together and provide customers a way to manage their deployments too. So the idea of this graphic is to show you the the kinds of systems that make up our deployments here. It is mostly, not entirely, it is mostly FreeBSD. There is plenty of Linux, bare metal running on hypervisors, etc., and a bit of kube. I mentioned some of the more standard business applications. That'll make up those will run on kube and resemble sort of a modern architecture. But that huge backbone of ridiculous throughput network all runs on a very, very large deployment of bare metal FreeBSD machines. So that I think would probably make us not perfectly unique, but a little bit odd in terms of an integration from most AI companies. So I'm trying to say, like, this is not this description of our network and we as a customer for someone like Resolve, this is not the happy path. This is certainly not something that they expected when they woke up in the morning to come in to try to work with us. It is most certainly absolutely not hello world. It is large, it is complex, it is performance sensitive. And I'm not saying this to try to impress you or to try to say how great our operations are. What I'm trying to say with this is that if we can make this work without having to build our own monstrosity from scratch to assist us in AI operations, it's pretty likely that most people can, because we're off the beaten path a bit, and we were able to make this work with Resolve. And I can talk a bit about, and we'll talk a bit about the ways in which you can handle that extreme bespoke customization. When you are operating at a scale like that, all sorts of bad things happen. Invariably, a lot of bad things happen. And I'm going to define some of these terms pretty broadly. But in a month, there are 150,000 alerts of some kind. Now, that term, there's a variety of observability systems that make up that 150,000 alerts. And I'm sure all sorts of people at Zscaler might like to argue with some of these numbers, but there is a bunch. Those alerts, sometimes those get remediated with automation. They get funneled to a system that automatically remediates them. Some of them go to humans to be addressed. Some of them raise incidents. Some of them get ignored. Maybe not permanently. They become something that are aggregated and evaluated over time to look for patterns. But it is the volume of those is incredibly high. The number, of course, gets smaller as time goes on, as we've been working with people like Resolve. But from those alerts and even other mechanisms, about 120 incidents per month are raised that demand someone like me that does incident command to go in and manage a bridge-based incident. Now, there's a lot of other kinds of incidents that are managed with different disciplines throughout the organization. But for me and my team, which is more your operational kind of incident, we're looking at about 120 of those. And Josh was mentioning a customer that had bridges of 100 people. Sure, I've seen that. I think we do try intentionally to keep the numbers a bit lighter, but 30 or more people could go through a bridge in the response to a particular incident. And like a piece of observation from my side is generally the more severe an incident tends to be, the quicker the resolution I tend to see, or the quicker I find that I can drive a resolution, because that's when you get all the resources you need. They tend to be very obvious. They tend to be discovered early. So there's very severe incidents. They can be quick. Incidents that are maybe lower severity that apply to a smaller set of the customer base, or just a data center, or just a box, those can take a bit more time. They start to get a bit needle in the haystacky. They might not be as impactful to the business, but they certainly are a pain for me. And a lot of those, well over an hour, a lot of those lower severity incidents. And I think of this all through two lenses. How can I help the company, and also, like, how can I just help myself and keep myself sane on some of these difficult incidents that we have to deal with. Um, we are what we're offering to our customers here. It isn't just software. It isn't just some filtering and security inspection software. Like, our product is that software plus the network itself. So that is a lot of surface area for different kinds of incidents that we're going to have to deal with, and disciplines that we're going to have to engage with in order to resolve those incidents. Kind of obvious normal things happen to us just like anyone else. Customer misconfigures their deployment. There are problems. We have to help fix that sometimes. We screw up the configuration of our own infrastructure. Of course, we'd be involved in fixing that. An example that I have here on the screen, undersea cable cuts, that isn't an exaggeration. That is the kind of thing that at least is going to show up in an alerting mechanism to us. A piece of fiber along the road next to a small country road, someone breezed on that wrong and there's increased latency. Someone at Zscaler probably knows about it. And those are the kind of things that there are plenty of tools out there, AI-based tools out there, that just aren't quite prepared yet to deal with, but are a requirement to operate in our domain. And of course, bugs, all software has bugs. Some of them are written by you, and you need help fixing that. And these domains plus more are what we rely on and are looking for AI-based operations tools to help us with. So what incident response looked like in that environment with all of those disciplines, all of those kind of problems, and to a degree certainly still does while we work on it. It's kind of like this diagram here with me on the left, where I'm the engineer sort of really quarterbacking it. Really should change that. I should probably change that to quarterback. Yeah, I'm trying to command and run this incident so that we can get a resolution using the resources you see listed here. There's going to be engineering teams. That's the app and product teams. Might start out with one, the team closest to the symptom. And as we figure out more in the incident, I'll page in another team and another team. The next thing you know, I could have talked to 2, 3, maybe even 4 teams. That is a lot of paging people, waiting for them to show up, getting them up to speed, and working with them to try to get a resolution. Other disciplines as well, right? Obviously, networking folks, systems engineers, the operating system level folks, and support teams. They're probably already present in the call, but the folks who maybe took an initial customer report that led to the incident, all of these people may have to get paged in or come and go in the course of an incident. And every person that gets added, that is additional time, additional context. And mostly, not entirely, but also mostly people that we'd prefer would be off building awesome things rather than sitting in an incident helping me fix the thing. But we combine them with the kind of resources you see at the bottom. I'm going to talk about 2. CloudFuse, our observability solution, logs, metrics, that kind of thing. We're using those in our incidents, but also an awful lot of custom observability solutions. and it's sort of the second box to the right at the bottom there. There is, because we are as bespoke as it comes, those custom tools are super important to our response process. So you join all of this together. If I do my job right, I can get a resolution. But there are a lot of things that I mentioned there. So we have hundreds of thousands of machines. We have a whole bunch of teams. So I get a bunch of systems, a bunch of applications, and a pile of people. But in the end, there's really only a small handful that were really relevant to the cause that I was trying to fix. So I need to filter out what isn't relevant so I can get to what's relevant. I can do that with my own deductive reasoning, and that's fun. That's what I've been doing most of my life. Or I could have some robots help me out with that, and that's what we're trying to accomplish with AI operations tools is trying to filter out what is irrelevant to focus on what is relevant. So if everything works right, we end up with a desired state that looks like this. It's probably a bit of a pipe dream, but if we can get it down to just one person who can just speak with the agents to get the answers they need to troubleshoot incidents, then we're doing all right. That's our goal. So with that being our goal, we figured, you know what we need? We need an AI SRE. We need a robot SRE to help us out. And there's plenty on the market. There were several that we were having a look at. And how are we going to pick? How did we end up with Resolve? Well, a lot of the offerings on the market were, for us, for Zscaler, absolute non-starters. If they require, the quote perfect stack, a perfectly modern kube stack, like that, plenty of people I could work for. Certainly isn't going to work for people with hundreds of thousands of bare metal FreeBSD machines all over the world. We need someone who can deal with our high throughput bespoke, built for us stack. And once we found the list of people that could satisfy that requirement, then we'll take our apps that have the best instrumentation now, and we'll test them out with a bunch of AI operations tools to see who does best, who can root cause those best problems with those best. We figure we can always catch up the instrumentation in applications later. That's something we can always improve for any lagging applications. Changing that stack, that is hard and expensive. So we need to filter out everything that can't handle us first, then take our best apps and see who performs best. And we ended up with Resolve. Going to talk about the top 2 points that we looked at very closely, and then the top 2 bottom points where I think we learned that you all should probably think about. Wish I was thinking about them early on because they were sort of emergent ideas that popped out as I've been working with these tools over the last year. The name of the game, the most important, the North Star, if you will, of AI operations is root causing your incident. And that has to stay front and center. It cannot be the only thing you worry about, but it has to be at the top. Fundamentally, that's how we ended up with Resolve. They won the competition that we had to determine who could root cause the best. And of course, adapted to our bespoke infrastructure. Anyone who couldn't was filtered out immediately. Things that emerged through both our POC and also our own investigations afterwards are, generative AI applications are very, very good at sounding confident all the time. And that actually is kind of useless to me. What I need from the tool is a very accurate estimation from the tool of how confident it actually is. And giving me a root cause that it is confident about, that is great. I really like it when it is a bit less sure and it can tell me like, hey, human, you actually have to get to do some work for a change. You can't have me do all the work because I have a couple of theories here, but I'm 10% sure. What I have discovered is it's sort of those mid levels and lower levels of confidence that when your tools can very accurately nail that level of confidence for you and communicate to you, actually, maybe you should look beyond some data sources that I have. That is helpful because there's nothing worse than being confidently told something is true when it's not. Another way that I would recommend folks evaluate is, especially in alert response, like I absolutely love getting a bang on great root cause from the investigation into alert. I almost love it more when it does an investigation and tells me, actually, that was a false positive. One of the things about a lot of AI tools is that they're very good about agreeing with you or very good about agreeing with the concept of your investigation or alert. And I don't want you to agree with me. What I want you to do is tell me, actually, your alert was wrong, and here's why. That is useful for a handful of reasons. One, I can then deprioritize my response because it was a false positive, but also maybe queue that up for a look at some denoising in the future. But that is, a false positive is something I would absolutely recommend that you test against. And that was an area that I think we discovered it because of how well Resolve shined in that regard. But after we selected Resolve, we more or less put something together based on the components that you see on the screen here. We bought Resolve. That's how we ended up in this conversation today. We use CloudFuse as our observability solution. There's going to be a few other things added on to there over time. CloudFuse is where we started. But we are a little weird, because of that giant, crazy bespoke architecture that we have. We had to build, I labeled it here because I was trying to be descriptive, system dependency graph. The official terminology, as Josh was using earlier, was knowledge graph. We had to put together a graph of this. These are the relationships of all of the bits throughout Zscaler. It's a lot of bits, by the way. That is, for an awful lot of you, even at large scale, you probably won't have to do that, as there are a variety of mechanisms that Resolve will be capable of getting such a data source. But for us, this was something that we had to bring to the table to adapt it to that crazy architecture that we had. And it sort of looks something like this. You'll, again, probably not have to worry about this, but there's a big JSON document. The vertices are things, applications, data centers, whatever. We have a bunch of all of that. And the edges are relationships between them. So this server over here uses that server over there. And that's basically what the dependency graph is. And after supplying Resolve with your data source, CloudFuse, and the dependency graph, well, it works. Here is a heavily redacted screenshot of an alert investigation. It's actually kind of an old one, but an alert fired within our system very quickly. We got a response indicating that it was a DNS. It's always DNS, right? But we got a response indicating that DNS resolution had failed. And it was interesting. The anecdote behind this one is this was very early in our evaluation process. This actually came far before we were in prod. And it was like the day we integrated this alert, a couple of days after the alert became followed closely, and almost immediately proved that, like, yeah, this alert had auto-investigated a couple of hours before we as humans even were looking at it. So that was a positive solution. But that's sort of what we got together. We got to the point that we have our data sources integrated. We're using them. We're in production with Resolve. That's fantastic. We have a big organization with a bunch of teams. So we are bringing and onboarding them now, starting with incident responders and application engineering teams. And it is important that both kind of those disciplines are well represented. Mainly those incident responders, we're getting them up to speed because they're going to be the primary users. But those product engineers, while I want them out of incident response and off doing their job, they're a great source of information and knowledge about your applications. So I want them engaged to help contribute to the knowledge bases in Resolve so it understands their systems and applications better. Second, there's all sorts of great opportunities for Resolve to help them fill in the gaps that they have in their dashboarding, answer questions for them. Whenever everything fails, it's good to have, sort of a robot to fall back to where they can get quickly in natural language debugging information for the problems they're having in production whenever everything else fails. And at first, especially with some of those incident response teams, we had to kind of get behind and push. Here's Resolve, use it, use it, use it. And once I think you would see similar things in your organization too. Once people get their hands on it, now it's Thursday, it's the fourth day of the week. 4 meetings I've had of teams trying to get on to the platform this week. So, at first you kind of got to get behind, hold people's hands, show them how to use the tool, show them how to build great prompts, show them how to manage their knowledge. And once they become efficient, you got to start them with a bit of a white glove approach. Then everyone's going to want to get on, and you're going to have an easy time of it. But it is very important while you're bringing on these teams. Don't just teach them how to investigate. Don't just teach them how to chat. You got to teach them how to become teachers themselves, how to provide knowledge. Largely, this is in textual form, descriptions of any dashboards you have. Teach those product teams who understand their systems how to become great teachers for the AI. And it pays off. You inform those robots well, and then that same person who did the hard work of, and not even that hard of work of just helping to collect some of that knowledge for you, then I'm probably not going to have to page them at 2 a.m. to wake them up to come fix the problem, because the robot would have got me there already. Um, to kind of recap that one, teach your teams, teach them how to fish. Don't just say, "Hey, here's Resolve, have a go at it." No, you will get a lot more mileage by sitting down and really teaching people how to prompt engineer well, and teach them how to really manage their knowledge. Prompt engineering, it might sound obvious, but it isn't always obvious to people. And really try to get these teams engaged to feel like there's owners of this, so that they own their knowledge. So as new products come into play, new dashboards are created, new features are added, they're there to help manage some of the knowledge that you have for that. So now that we're getting people engaged, where is Zscaler going next? Most of this you saw at the bottom, but we focused on that initial, where the bulk of the problem is, where the bulk of the data is, our primary observability solution. Now that we're good there, it's time to turn our attention to some of those other very custom observability solutions we've had, like entirely internally developed. And here is, I think, a point that could also be interesting to a lot of you who really want to build something, not just buy something, or you're in our camp where you have a lot of highly custom stuff. With MCP and custom tools, the next bit for us is to expose a number of those really high value custom observability solutions we have, so that they can be used in our investigation. And I'd imagine a lot, especially the larger people with larger deployments out there, would have something as well. But this is a nice part of the seam where I, as an owner of the AI ops space, I don't have to go out there and I don't have to go build my own agentic AI SRE system just because I have a crazy, highly customized and bespoke network. I can work with Resolve. I have to do the work of giving them a knowledge graph. I can build MCPs and whatnot to fill in any gaps for interesting data sources. And then, as they say, Bob's your uncle. But that is what we are doing at Zscaler. We're trying to make, happy robots doing SRE stuff with happy humans, hanging out at the water cooler, doing some work together. And that is what I had for you all today.
Awesome.
All right. Thank you very much, Chris and Josh, for your time. Loved hearing about your story at Zscaler. Chris and Josh, thanks for hopping in and answering all those technical questions. As a reminder, we will be following up with the resources from this session. I believe we answered the questions that came in, but again, if you do have any questions that were unanswered, feel free to respond to our outreach. We will make sure that you get the answers you need.
Yeah, there's a couple questions, and if we have time, I'll go back to some of those chats that I had earlier. But Chris, thanks for the presentation. It was awesome. It's been awesome working with you. one person asked about your scoring rubric, and they said, "What was resolve score in root causing?" So just to preface this, one of the way like AI SRE, like nobody knows how to test them out, what's realistic, what's not. You throw like say a log into Claude and you're like, okay, we can do anything. And it's like, yeah, maybe, probably not. And so one of the ways that we guide customers is we'll do some back testing. Like give us some recent incidents, knowing the data that we have access to during the pilot. But then also like there is this level of like, well, let's test the boundaries and limits of what it can do with unknown incidents or like when Chris talks about prompt engineering, it's like how refined should my prompt actually be? Because you know someone's going to come in and be like, "Hey, everything seems to be a mess. What's going on?" And so, Chris, someone asked, like, "What was resolve score in root causing?" I actually don't know if I remember exactly where we ended up.
Yeah, you were at the top. Frankly, there honestly were a handful of other like I'd have to go, but this was because this was a while
Yeah.
ago, right? But that was you were at the top, and that's why the selection occurred. But there were plenty of other organizations that did well as well. And what it came down to is beyond just the root causing, some of the other things that I mentioned, of helping me get to the false positives, that kind of thing. It was stacking up the big picture overall, as well as adapting to the infrastructure. That was why, like that pushed it far over the edge where it's like the root cause, you were on top, but a lot of people can do that right. It's a lot of the stuff on the side that was useful as well. The rubric, it was based on what you said, in a sense, where we used Likert. The thing is, at the time we were still getting started, we were using Likert scales and SREs, so actual human beings who do incident response, and we'd walk them through scenarios that came from actual incidents on our applications and said, 1 through 7, how did it do across a matrix of problems? So it was based on their assessment, frankly. But that was what we chose to do at the time.
Yeah. It is fascinating. Like when we so one of the challenges that you run into with an AI SRE is it's like, oh, it's an AI SRE, so the SRE, maybe the platform team should be involved. But when you actually look at incidents, they're not solved necessarily by the SRE. They're
Hmm.
solved by the person that wrote the code or is responsible for the code of where it existed or knows that domain the best. And an SRE can mean a lot of different things. And so when we think about like what is the value of this AI for prod or ARS3, it's like, is it helpful in X percentage of the types of prompts, whether it's an alert or it's somebody that comes in and says, I'm new, tell me about my backend services, what's it running on? Have we seen anomalies in the last hour, stuff like that. Like these are all flavors of the same data. And that's really what goes into kind of the criteria of, hey, is this thing going to provide value? There's one other question, and I'll paraphrase it, Chris, where it was like, can you help us understand, like, when you brought, say, these AI ops tool or whatever, AI SRE, whatever it is, when you bring it to management, like, what is the value that they actually see in it? Because, like, we've been talking about AI ops for over a half dozen years, and
Sure.
it was like, how do I group alerts? How do I do some workflow automation based on an alert, route it to the right person? That was AI ops at some point, where it was like mapping metadata and
Yeah.
configuring workflows. Today, of course, now we're actually in an era in AI, so it changes the meaning a little bit. But like maybe like a success story when like your chief reliability officer was like, okay, like observability data won't be enough. We have to add something else on it. And then what did they see where it was like, okay, this is obvious? And I would imagine that has to be tied to a business problem.
Sure. The categorically from senior leadership, what their drive has been from the beginning is that they're trying to decrease mean time to mitigation. That is, by far, that is what they are laser focused on. It isn't the only goal that we have, but that is the goal that is coming from business, and especially in our case, every the minutes of any kind of downtime as those are added up, those do have a financial impact on us. So that's what we're trying to minimize. And the one screenshot that I showed about an alert that was investigated and proven before we even were looking at it is an example of where there was, well, now there is I'd have to think about an investigation that didn't actually happen. We'd have to assume there's probably then about an hour of human investigation that didn't have to occur. So if anytime I can make an amount of investigation not have to happen, that is saving me time. And anytime I can remove people from the bridge, from having to be paged into the bridge, then one, I can let them do their job, but also decrease at least whatever, something less than their SLA was they would have added on to the incident. But laser focused from senior leadership is driving down MTTM is the name of the game for them.
Awesome. All right. Uh, any other questions? Or I could bounce back to the demo for a minute. What do you think, Chris? You want to see how that ended up?
Yeah, I want to see the conclusion.
All right, let's go back to it. So remember when we were chatting with that alert? So we chatted with it, and then I asked. So this is a nice thing, like your Slacks and your UI, it all carries over. Of course, a UI is where you can get all that context. I said, at Resolve, is this still going on? So it investigated the alert to see if it had been resolved, as well as the metrics to see if they had kind of plateaued or gone back to normal. And so this is what happens like all the time for on-callers when they're on their phone is just like, just tell me if I actually need to stop and get back to this. And it says, look, it actually was resolved. Current status is this, what happened? Then within the UI, I'd asked to create a PR to permanently disable it. So by integrating with your code, now one, we can understand the code. That is hugely important because if we see a deployment and then we can track that back to the the PR, then now we can get to causality. Without that, like we can tell you, yeah, it looks like this deployment, but you go and sift through 13 PRs to figure out which one it is. And so here it generated the PR where it disables the flag, why this helps, and so forth. And so that's kind of where you see it go. Um, and one other quick one that is fun is so once you have access to all this data, you can do stuff like this, like where you can generate slash commands or knowledge that you put in. Say, whenever I say this and a service name, create a report that looks like this. So tell me about the service, the infrastructure details of it, the operational metrics over a period of time, resource utilization. Like this is the thing, this is the value of AI. It's like all the stuff that you really wish you were doing and if you had more time, but you're like, you know what, that's a heavy lift. Like, and this is what this enables you to do. It's like, it's kind of bonkers. We internally, we have an Ask Resolve channel where all day I'm like, hey, why didn't this canvas, well, not all day on this one, but why didn't this canvas, like, why didn't this chat finish? Or this, like the other day, a customer was like, yeah, I clicked this environmental variable and it doesn't look like it used it. So I asked Resolve, hey, check the code. Does this variable actually get used anymore? That's not me going to an engineer and stopping them. Anyways, I can like do this all day clearly, but thank you for joining. Chris, any final words?
No, that was awesome, and thanks for showing us the conclusion there.
Whew. All right, everyone. Well, have a great day. Thank you for joining, spending an hour with us. It means a lot, and I guarantee in a month, 3 months, it's all going to be even more exciting. So have a great one.
Bye all.